Hey everyone, it's Mr. Lightfoot. I just want to show you a quick example of how we use the distance formula. I was trying to help one of you earlier and got cut off, so I figured I better make this video for you so you still get that help. So the distance formula is telling us how far apart 2 points are. Now, if we have 2 points that are vertical from each other. Like let's say I have, let's see, that's 1, 2, 3, 4, 5, 6, 7, 8. So I have a point at 8 on the y-axis and a point at 6 on the y-axis. It's not going to be too hard to say, oh, they're 2 units apart because I can just do 8 minus 6. Okay, super not difficult to do that. But it becomes a lot trickier when a line is diagonal. If it was going horizontal straight across, it would also be very easy because I could just subtract the one coordinate on each side. But when it's diagonal, we're going to use both coordinates. All right, so the formula looks like this, which can be kind of intimidating for a lot of people. There are a lot of parts, a lot of symbols, and just looks like kind of a headache. But I think you'll find that it's actually not that difficult. One thing to know is that you're just going to use the coordinates. So for this problem, I'm going to use points A and B and find the distance between the two of them. So I'm going to use the x coordinates and the y coordinates. So I'm marking the x in yellow, marking the y in green. Now, if I follow the order of operations, you remember, please excuse my dear Aunt Sally. If I apply that to this problem, the first thing it says is parentheses. We're going to do everything inside parentheses first. Now, one of the things I don't like about PEMDAS as a way to remember things is that P doesn't actually just mean parentheses. It actually means any grouping symbols. And if you look at this formula, the whole thing is underneath a big square root symbol. So you cannot actually, if you're trying to calculate the square root, that would be the last step because that puts everything inside it in one big group, and that whole big group needs to get boiled down to one number before you can start working on getting the square root of it. So the whole time we're actually inside that grouping symbol, but we're going to run through PEMDAS inside there, and then we'll do the square root last. Okay, so inside the square root, we have two sets of parentheses. Each of those says to subtract. So I'm going to do that. I'm going to subtract the two x's. Again, that was the ones I underlined in yellow. Now, it says x2, x1. It doesn't really matter which one you call the first point or the second point. I'm going to call it this. Okay, so x sub 2, so the x of the second point would be negative 3. And then I'm going to subtract the x of the first point. That's 3. And I'm going to do the same thing with the y's. I'm going to take the y of the second point and subtract the y of the first point. All right, so if you use your calculator, because I know these subtracting integers can be a little tricky, you can use your calculator. So negative 5 minus 6 is actually negative 11. And negative 3 minus negative 3 is negative 6. Okay, so that's the first step. We did the subtractions. Now you notice in each of these parentheses, there's an exponent outside. It says to square it. So we're going to take the negative 6 and we're going to square it. That means multiply it by itself. I'm going to do the same thing with the negative 11. Okay, now the reason I put parentheses around there, if you don't put parentheses around that negative in the calculator, it will give you the wrong answer. So this is 36. And this is positive 11. Excuse me, positive 121. Okay, next step is to add those. That's step 3. I get 157. And the final step will be to get the square root of 157. You plug that in the calculator, and you'll get about 12.5. That's it. That's the